than what we did with experimental probability. Theoretical probability and experimental probability is something that you should know the difference between by the end of this lesson. You should be able to calculate the theoretical probability of different combinations and events, and you'll be able to express probability as both a decimal and a percentage. So when we look at experimental probability, experimental probability is the probability we get by actually doing something, right? Versus theoretical probability is what we're expected in some events. So this is before we even do this, right? Like, what's the likelihood of this happening before we even actually go ahead and spin a dice, before we even go ahead and flip a coin or pick a card, right? So in this situation, what's the likelihood of rolling a 3 on a 6-sided die? If we think about it, there's only one face that has a 3, and there's 6 options. So we know for a fact that in between them, there's a 1 in 6 chance that I'll roll a 3, or 16%, right? Or 0.16. If we're going to flip a coin, you're either going to land on heads or you're going to land on tails. So there's really 2 options. So the likelihood that you're going to get a tails on a single coin is 1 in 2, or 0.5 in a decimal, or 50%. We know there's a 50-50 chance, right? A little bit harder now. If we go over and we think, what's the probability of getting an ace in a deck of cards? We have to think a little bit. How many total options are there in a deck of cards? 52. There's 52 cards without the jokers, right? And how many aces are there? So there's the ace of spades, there's the ace of diamonds, there's the ace of clubs, and then there's the ace of hearts. So there's 4 aces in the entire deck. So the chances of us pulling an ace are 4 out of 52, which is either 0.0769 or 7.69%. Right? So that's how we kind of find the theoretical probability. This is what we expect. This is before we even go ahead and do anything. So a great example of this is, if we think about it, example 1 is you're playing a game with your friends and you flip 3 coins according to the following rules. So here are the rules. The first rule is that if you get all 3 tails, you'll get 3 points and you get to try again. If you get 2 tails, you get 1 point and you get to try again. If you only have 1 tail or no tails, you'll lose your turn, no points, right? So let's go ahead here and list all the possible outcomes we can get from flipping these 3 coins. Personally, for me, I like to start off with the tree diagram, but for the purposes of this class, I'm going to actually start off with the possibilities that we have. So let's start off with our first possibility, which is we flip the coin, and the first coin we get is a heads, the second one we get is a heads, and the third one we get is a heads. Then we can flip the coin, and the first one we get is still heads. The second one is still heads, but the last one we get is a tails. Then I go ahead and I'm going to flip the coins again. I'm going to get heads again as the first one. Then I realize I get tails, and then I have heads. Right? I'm just flipping the coin. Then I can go on to 4, still have a heads, and then I have, say I get 2 tails and no heads. Now I've kind of exhausted all the possibilities I had if I had flipped heads as my first one. So now I got to move on and just say, okay, what if my first card or my first flip, I landed on a tails, right? Then after that, everything I got was heads. Then the second possibility could be, say the first one I landed on a tails, and then I got a heads, but then I landed on a tails again. Then I could have the possibility of starting with the tails, landing on a head, landing on another tails, right? But the last one is heads. And then last but not least, the last possibility I could have is that I get all tails, right? So there's 8 possible outcomes I have here. There's 8 possible combinations that I can have. You can draw these in something that I call a tree diagram. And for me personally, I like tree diagrams. I think they're just easier to understand. So I'm going to write this out. This is a tree diagram. And let me show you how we draw those. So we start off with our first coin. So I'm going to say my first coin, I can either get a heads or I can get a tails. I only really have 2 options here, 2 possible combinations. Then I can branch out and I can go and say, okay, from the heads, my second coin can either be a heads and another head, right? So I'll write this in orange. Or I can branch out and I can get a heads and a tail, right? So if I flip the second coin, I can either get head or tail, and then now I have two possibilities. So let's just deal with our first one as a heads first. So let's just say we've got a heads for the first one. What are our possibilities? Now I have a heads, and then I have either heads or tails as my second one. Now if I want to see for coin, that's for coin 2. On the flip side down here, I have a tails, and I can again get either a heads or a tails, right, on my second coin. Heads or tails. Then it gets a little bit more complicated because now we got to go and figure out, okay, let's do this with our third coin. So say our third coin, I can get either a heads or a tails here. So I'm going to do my third coin in pink. Heads or tails, right? Then again, if the second coin was a tails, I need to have either heads or tails, right? And then here, I'm going to say the same thing. I have either heads or tails, right? If I had a tail and a head, and then I can have a head or a tail. And then I'm going to flip again, and I'm going to say, okay, for my third coin, the possibility is heads or tails again. So notice how when I only had one coin, I only had 2 options. Then I moved up to having 2 coins, and now I had 4 possible combinations. I could have had a heads and a heads, I could have had a heads and a tails, I could have a tails and a heads, and I could have a tail and a tail. Then when I move on to my third coin, I add even more options. I can have a head, 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 head. I can have a head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, 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 right? So now I have, on this end piece, I have 8 possible combinations, which we know is true because we already counted 8 possible combinations. This is just an easier way to find those combinations when you move on to more difficult concepts. So maybe you had something that was 3-sided die, right? And then I had 3 sides and I was rolling 3 dice, right? I would have a possibility of 3 times 3 combinations. Okay? All right. So let's go on. So these 8 event outcomes can be grouped. So if we go back up here, they can be grouped into these events, right? Because what we're actually looking for isn't necessarily the specific combination. I don't care if I get a heads on the first round and then 2 tails after, or if I get 2 tails on the first 2 rounds and then get a head after. I just care that I got 2 tails, right? So that I can get that 1 point. So what you're looking for now is you're going to actually define things as an event. So I'm going to say, okay, if there's only 1 tail or no tail, you lose your turn. That's going to be my first event. That I'm going to label as event A, right? That's the one that sucks the most. It's the one that I don't want because I don't want to lose a turn. So that's event A. Event B will be the second one, right? Where it says there's 2 tails and you get 1 point. Kind of sucks less, kind of what I'm aiming for, right? So we'll write this as event B. And then the last one is going to be event C, which is kind of like the ideal situation where if I get all 3 tails, I get 3 points and I get to go again. So this is event C. Now I got to go and group these, right, as those different outcomes. So let's go and find all the event A possibilities. So I'm just going to highlight that in blue, right? So everything that has only 1 tail or no tail. So number 1 only has no tails. Number 2 has 1 tail. Number 3 has 1 tail. Number 4 has 2 tails, so that's okay. Number 5 has 1 tail. Everything else has 2 tails. So that means outcomes 1, 2, 3, and 5 are going to fall under event A. So I always like to highlight. I find it easier to work with the highlighter. It's more visual for me. Let's go find event B. So event B says there's only 2 tails. You get 1 point and you get to try again. So let's find the one with 2 tails. There's 2 tails here, 2 tails, 2 tails. So there's 3 possible outcomes that will get us to event B. And then event C, the most ideal event, which is I get all 3 points and I get to try again, is event 8, right? Or outcome 8, and that'll get me event C. So let's find the probability. What happens when you list the outcomes as events is it just shows you a clear indication. Now I can just go back and I can actually find out, do I know what I'm looking for and the probabilities I'm looking for? I have a visual representation, right? Instead of just having to go back and like count every time, right? So in this case, we can actually calculate theoretical probability for each of these events. So let's look at event A, right? Our event A was blue. The chances of us not getting any points and losing our turn are all the blue options here, which is 1, 2, 3, and 4. 1, 2, 3, and 5, right? So we're looking at the number of times that that event can occur, right? The number of times that that event can occur is 4 times. So probability of A is equal to the number of times that it can occur, which is 4. And the total possible outcomes, which we said was 8, because there was total possible 8 combinations, right? So now I just need to reduce this so it becomes 1 over 2. You always want to write it in the lowest terms. So if I go back here, 4 represents the 4 specific ways or 4 different ways to get no points. To get no points, right? And then 8 represents the 8 possible combos. You can get. And then 1 over 2 is just this in lowest terms. Okay. So then part B, or probability of B, you try doing them yourself. Go how many ways can we get event B? How many ways can we get event C? Solve them yourself and then come back and watch this. Okay, so hopefully you pause the video there. Let's go back and see. How many ways can I get event B? Event B for us was the yellow one. Let's go back and see how many ways we can have the yellow outcome. 1, 2, 3. There's only 3 possible ways, so that means it's 3 over the total amount, which is 3 over 8. 3 over 8 is already in lowest terms, so that's just the answer. Then let's look at probability of getting event C, which was the ideal one where you got to keep all your grades, and we said that all your points and try again, which is 8. So it's only 1 out of the 8 that you could get that, and 1 in 8 is already in the lowest terms. So let's go put each of these probabilities as a decimal. To get 4 over 8 as a decimal, you're just going to do 4 divided by 8, which is going to be 0.5. And I like to just go ahead and do the percentages together. So if you're going to rewrite each of these probabilities as a percentage, to turn 0.5 into a percentage, you just move the decimal place over 2 and you get 50. Or you can just multiply by 100, which would also give you 50. Right? Probability of B is going to be 3 divided by 8, which I know gives me 0.375, right? Which is just 37.5%. I'm going to write them all in. And then probability of C happening is 0.125, right? Where I can just write that as 12.5%. Right? I just multiply by 100, got 12.5%. Any way of these, either as a decimal, as a fraction, as a percentage, are all acceptable ways of representing the probability. So by forms, what I actually mean is as a percentage, as a decimal, or fraction. But the fraction needs to be in lowest terms. Okay? Moving forward, we're going to do example 2 together as well. Try doing this one on your own. It does require a little bit more patience because there's way more information here. But what we basically did here is just trying to find the sum. So if you were to solve something like this, and if I asked you how to calculate the probability of rolling a specific sum on 2 dice, there's this easy way to set this up. You're going to take the first die, right, and you're going to write all the numbers across. So I'm going to take all the numbers that are on the first die, which is 1, 2, 3, 4, 5, 6, write them across. Then I'm going to take my second die and just write them going down. Also 1 to 6. Now that you have this chart, right, what you can do is just fill it out. So you can go in 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1, and you can fill it out that way, right? And then, for example, you have 4 plus 3 is 7, so you get 7 there. So it's an easier way to fill it all out using your sums. I already did it for us, that is easy to use, right? So we created this chart to find the possible sums. Let's see what the possibility of rolling these sums are. So if we think about rolling an even sum, let's go ahead, use our highlighter, and go highlight all the even sums. Be careful to leave this column and this column alone because it's just the die faces. So leave the bold column alone. Let's use pink. Let's go find all the even sums. So I have 2, 4, 6, 4, 6, 8, 4, 6, 8, 6, 8, 10, 6, 8, 10, 8, 10, 12. So if I go and I add all of those up together, I count it out, there's 18 possible even numbers out of a total of, just go ahead and count, 6 times 6, because it's a 6 by 6 cube, is going to be 36. So 36 options. So 1/2 of these, or 50%, or even 0.5, whatever you would like to write it as, are going to be even numbers. Let's go ahead and find our odd sums, right? So then we're just going to go and find everything that's odd. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Again, there's 18 options that should be odd, 50%. So that makes sense. About half of them should be even, half of them should be odd. I'm just going to go ahead and erase this so that we can do our next set. So the next one says, what are the chances of rolling a sum of 7? So let's go find all of our 7s, which is really easy because they're all just kind of going up this way. 1, 2, 3, 4, 5, 6. There's 6 7s, so we're going to do 6 divided by a total of 36 options is going to be 1 over 6, or 16.6%. Rolling a sum of 7, so 7 included, or less. So we're just going to leave the 7s highlighted. Let's go find all the numbers less than 7. So we have 1, 2, 3, 4, 5, 6, 3, 4, 5, 6. Everything gets higher. So I'm just going to go count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 18, 19, 20, 21. So I know 21 out of 36 of my sums are going to be less than 7. So then I just do the math, right? So it's going to be 7 over 12 if you want to do the reduction. Or when you divide 7 divided by 12 is going to give me 58%. That means about 58% of our numbers are less than 7. So let's go and find how many of our numbers are greater than 7. Right, we're just going to go count the rest. Another thing you could have done is you could have just done 36 minus 21 because the rest of the numbers are going to be greater than 7. Or if you want, you can go count. But if I did 36 minus 21, I'm going to get 15, right? Divided by 36. And again, if I went and counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Doesn't matter which way you do it. It's going to give me 5 over 12, or 41.6%. It should be 41.7. So the thing with theoretical and experimental probability is that theoretically you should get this. Theoretically, about 50% of the time when you roll those 2 dice, you should get 50% of your number should be even, 50% of them should be odd. But you'll notice when we did experimental probability, they weren't exact, right? So what happens is that theoretical and experimental probability are not necessarily the same because there's always room for error. But as number of trials increases, the experimental probability usually gets closer to the theoretical probability. So if instead of 50, we had done 100, you might have gotten more of a 50-50 split. If instead of 50 you do 25 trials, you're going to see more room for error. That's why when you do science, you are always told to do multiple trials of your whatever you're looking for. And that's because multiple trials just increase the reliability and the what it should be in theory. Okay, and that is it for theoretical probability.